Welcome to today's Energy Central Power session entitled Cyber Resiliency in the Power Industry. A few housekeeping notes we'd like to mention. We acknowledge that given the higher demands on internet connections, where many are working from home, technical issues may be more pronounced. If for any reason you find the need to restart the event, we invite you to click the same link to rejoin us. All mics have been muted. If the sound is not clear on your computer speakers, you may dial into the audio portion using the telephone number listed in the right-hand panel of your interface under the audio section. Today's discussion is interactive with questions from the audience and the moderator. We are taking questions anonymously, so we encourage you to please participate and submit your questions at any time using the interface on your screen. Before we begin, I'd like to take a moment to thank our sponsor, Dragos. Dragos is the industrial cybersecurity expert on a relentless mission to safeguard civilization. Dragos, thank you for making today's event possible. Now I'd like to turn the floor over to our moderator, Christine Herzog, Principal Project Manager for EPRI, to kick things off. Christine, welcome to the event. You have the floor.
Well, thank you, PJ, and thanks everyone for your attendance here today. We've got a really great topic, and I'm excited to be focused on it. I do cybersecurity research at EPRI, and today's topic, cyber resilience, is relevant to research that I'm leading right now. So this discussion is going to be a rich source of information for me, and I hope for you as well. So let's get started. And I've got a first question to ask everyone, but before I get there, I do want to make sure everyone has a chance to do a little brief introduction of themselves. Phil, if you wouldn't mind starting off with just telling everyone a little bit about yourself, it'd be great. And then Spencer and Toli, if you could in turn do likewise.
Hi all, I'm Phil Tonkin. I work in strategy at Dragos. I've been in the power industry for the last 23 years before making the move over here to work in a dedicated cybersecurity company. My roles in the power industry have varied from working in engineering, in substations, in power stations, working on electricity and gas systems from transmission right the way through to distribution. And throughout my time, faced a number of challenges to the resiliency of those systems, from typical weather events, through to the more emerging threats of coming from cyberspace, and that's the what ultimately led me to have this new focus to try and help the energy industry, in particular, defend itself in the way it's defended itself against a number of other issues for many decades, and make sure that the lights stay on.
Thank you, Spencer.
So I'm Spencer Wilcox. I'm the Executive Director of Technology and Chief Security Officer at PNM Resources. We're a power utility located in Albuquerque, New Mexico, with operations throughout central New Mexico, northern New Mexico, and across Texas through our subsidiary TNMP. PNM Resources is a great place to work, and we're building a resilient infrastructure here. Now, that said, we're only as resilient as N-1, and one of the key challenges that we're experiencing and that we want to talk about today is how to deal with a human-caused hazard, in this case, cybersecurity. The reality is we have to build for all hazards, and we have to prepare for all of them. Just because there's a bad guy on the other end who intends to cause the lights to go out doesn't mean that we can shirk in our mission of keeping the lights on and the beer cold. So I look very much forward to having this discussion today.
Thank you, Spencer. And Toli, how about a little intro from you?
You bet. I'm Toli Clegg. I lead the operational technology, cybersecurity function, and IT governance function for Portland General Electric here in beautiful, rainy Portland, Oregon. We're just focused in the state of Oregon. We've got about 900,000 customers. I've spent just under 20 years in the utility industry here in the Portland area between a couple of utilities. Worked my way through engineering and SCADA, IT network administration, the full gamut of utility design and operation. So looking very much forward to discussing how do we keep the lights on for our customers today.
All right, well, thank you all. So let's just dive right in. And, the first question that I'd like to pose to all of you is really, how would you define cyber resiliency? This could be like smart grid, where depending on where you sit, it has a different definition for you. So let's see if we can, get everyone's answer and then achieve some kind of a consensus definition. So, Phil, I will start with you on this question.
It's there is a long answer and a short answer. The short answer is cyber resilience in the electricity industry is about keeping the lights on and being able to either protect and defend against and withstand a cyber attack, or to be able to recover quickly from that with minimal impact to the customer. Achieving that is it requires a vast number of different focus areas, everything from understanding the systems that you have, understanding how you will recover, who you need to engage, where the resources are that you need in order to do so, how you make decisions during during an event, such as a cyber attack. How are you going to weigh up and prioritize keeping the lights on versus gathering the evidence and making sure that the adversary is actually removed from your network? So it's an incredibly complex area, but it's something that I feel that the energy industry is immediately prepared for through all of the focus it's had on resiliency, since the energy companies were established. Keeping the lights on is the mission, regardless of the vector that causes that impact. And I think it's there's a huge amount that can be built on. We're just taking into account the fact that there's now this this new potential cause. So it's all about being resilient, being able to stand up against attacks and being able to recover from them should the worst happen.
Okay, well, thanks for that. So, two of the key words I heard there were the ability to withstand and then the ability to recover. So, Spencer, let's hear your definition. And I didn't mean to just summarize it like that, but I'm listening for the keywords, and those are good verbs there. So, Spencer, how would you define cyber resiliency?
So I have a one-sentence definition, and that one-sentence definition is: resilience is the ability to continue to operate even I'm sorry, let's start over. The ability to continue to operate even in a degraded state in a hostile and contested environment. So, whether we talk about storms in our industry on a regular basis, right? We talk about hurricanes, we talk about floods and earthquakes, and we've learned over, literally a century, how to build systems and build grids that are able to continue to operate even through those. There may be outages, but generally speaking, you don't see total black, right? We don't see us go to zero. And that's an important thing. But what we also have to realize is that from a cyber perspective, when you've got a witted adversary who has an intent to cause the system to go to zero, there is a need to figure out ways to ensure redundancy and reliability when we're dependent upon cyber systems. And that redundancy and reliability is a core component of all disaster recovery capabilities. It's a core component of all of our business continuity plans. But at the end of the day, it really builds or requires that we build people, processes, and technology, build out the capabilities to sustain the attack and to continue to operate through the attack. Okay, so when we talk about confidentiality, integrity, and availability in cybersecurity space, in my industry, in Toli's industry, we have to look at it completely inverted. It's availability, integrity, and confidentiality that matter. Confidentiality is important for our customers. It's important that we don't share information that we shouldn't. But the reality is, if we're not keeping the lights on and the beer cold, we're failing at our mission. If we're not ensuring that the systems are communicating in an effective way, that the integrity of the messaging between those systems is accurate, we're not going to be able to continue to operate. But most importantly, we have to keep it available and keep it running, no matter what the bad guy's trying to do.
Okay, I caught, thank you for that definition. I caught a couple of nouns there. Redundancy and reliability, were two things that, came front and center. So we've got a couple verbs, we've got a couple of nouns. Totally, I'm not forcing you into the adverbs or prepositions or anything like that, but can you give me a definition of how you would define cyber resiliency?
My degree was not in English, it was in engineering, so I would have to use a function probably rather than some of those other things. But yeah, no, I think there's not a lot that I can add to what both Phil and Spencer said, but one of the ways we think about it is really keeping the lights on for our customers through the use of, but also in spite of the use of technology. We've gotten to a point where we've become very dependent on that technology in order to perform our operations. How do we design systems that we can continue to perform that function when the system's working correctly, or when the system is not working correctly, whether it's a cyber adversary or a natural disaster, or whatever the conditions are that may lead to the system performance degradation. How do we continue to keep the lights on for our customers, serve their needs, meet their expectations?
Okay, great. So basically, there's a common theme here about staying operational. That is important, and even if it's a degraded state of operations, that you are going to remain operational. But then also there is this element of how quickly can you recover. So that implies some sort of an anticipation of what bad things could happen, so that you can then have the appropriate redundancies, backup systems or whatever. So let's talk about, when you're going about planning, how do you determine what are those most likely, what are the greatest risks, and how are you going to mitigate them from that resiliency perspective? And Spencer, you look like you're ready to jump in here, so I'll start with you.
Well, I am, and I'll tell you why, Christine. To me, this all starts with the engineering discipline of failure modes and effects analysis, right? So whether it's cybersecurity or whether it's plant engineering or whether it's transmission design, right? What we have to recognize is that there are certain failure modes that we should be able to anticipate. We should be able to anticipate the potential causes of those failure modes, and then we need to design or create design tolerances to ensure that those failure modes have either a backup, so hence redundancy, right, or have an adequate plan to ensure that the trigger can be avoided. So when you think about risk management, right, what we're really talking about is what are the possible things that we can avoid, that we can mitigate, or that, frankly, we can transfer, right? And so how would you transfer a risk of keeping the power flowing? Well, we can do that by transferring to, if we have a single substation, for instance, can we move to 2 substations? Can we kind of federate the risk across multiple platforms? But that requires that we consider those failure modes in terms of diversity. All right, so we have diversity of systems, we have diversity of processes, and then we have diversity of people, right? The systems themselves, I can add redundancy in, I can add secondary systems, I can add shunts and route arounds, right? From a process perspective, though, I also need to have processes that are planned so that we're not making this up on the fly, right? We need to be thinking about those failure modes in terms of what do we do when the bad thing happens, not if, when, right? And then we need diversity of people. Now, I say this, and I mean this in a couple of different ways. That means I can't just be one deep in my processes. And secondly, it means that I really need to take advantage of an environment where we have fewer people than are necessary in the technical industries, whether that be engineering or cybersecurity or IT. And let's assume that there are 3% of the population who are capable of doing this kind of work, right? Now, I don't mean that we're the top 3%. I just mean that there's a certain mentality necessary here, right? Now, when that's said, if there are 3% of the population that are available and we're not focusing on bringing in 50% of the population, because the majority of the population looks like me and like Toli and frankly like Phil and Christine, we're glad that you're in this industry, right? But how do we ensure that we are taking advantage of the full 100% of the population to get that 3%? Does that make sense? And then how do we ensure that we're retaining those people, training them, and building out a capability that's robust and that takes advantage of the thought processes of some of the most brilliant people in the world who may be underrepresented in our industry?
Well, there's a lot of, things to drill down into your response there. But let me just, ask, Toli a similar question before we, jump back into that about, the way, for the utilities that you've worked for, Toli, perhaps they have had similar approaches or maybe different, but, can you describe a little bit about the way your utilities have thought about addressing resiliency and the concrete steps that they've taken about it?
Absolutely, yeah, and I think Spencer touched on a couple of things that were both similar in some respects to those different utilities. One of them is planfulness, right? You absolutely need to have a plan in advance. You need to work methodically through that plan. You need to test that plan, and so I think the idea that you don't want to be making decisions during an emergency that you could have thought through in advance is an important part. He mentioned the failure mode and effects analysis, and I think of that. That's a thing that we use currently at Portland General. Also, just the idea of a business impact analysis. What are the important things to your company? How are those processes expected to deliver the results? And then what is the technology that either supports or is a dependency of that process? And thinking through all of those steps and really understanding this can go wrong at this step. How do I plan for that? Am I trying to reduce the impact of that problem? Am I trying to detect it before it occurs? Am I trying to mitigate it through some controls, be it cybersecurity or redundancy from that regard? So I think really being methodical in your approach, measuring it, testing it, those are all critical aspects of preparing for events. And again, resilience for us, we've had a number of events over the last couple of years at Portland General Electric that we've been through with once in 40-year ice storm and the wildfires that were unprecedented for our area. Other regions certainly have to deal with that more commonly than we do, and so that gave us a real opportunity to go through and understand what are the things that could happen to us or around us, and how do we then prepare for that, making sure, again, we want to keep the lights on for the customers because there's just no appetite for saying, well, that was too difficult or we weren't really prepared for that. That's just not an option for us.
And don't forget the heat dome. I remember the heat dome.
Oh, yes.
Well, thanks for that answer, Toli. Now, Phil, you deal with utilities, but you also talk to other, in this sectors of the businesses as well. So, is there a common theme here in terms of the way different types of businesses are approaching thinking about cyber resiliency, or are there some unique differences for utilities to keep in consideration?
Utilities absolutely have a very unique perspective on resilience. If you work in a manufacturing sector, whether it's a refinery producing oil or chemicals, whether it's you're producing food, or you're creating pharmaceuticals or cars, you can calculate the impact of any loss of your facility in the loss of revenue. And it's quite different for utilities because the service that they provide has become so fundamental to society that the immediate loss of energy in particular has an impact on people's basic ability to survive. Heat, light, fresh water, even to some extent the internet has been, these are critical utilities for us. You can absolutely map them into to the hierarchy of needs now, and so it is very, very difficult to calculate how a particular incident will manifest as a sort of dollar figure in terms of your the impact on your business, because the societal impact is so much greater than the consequential economic hit on a utility. Most utilities far exceed their levels of required resilience, and the utility I worked for the last 20 years was 99.99998% reliable. That's nearly 2% more reliable than it needs to be. So you can't really say to the people who need to fund a cybersecurity program, that if we were to lose our substation for a day, that would cost us an amount of money. It wouldn't. In reality, it doesn't. It have a direct fiscal impact. It can have some reputational impacts and things like that, but it's actually that recognition by utilities of the societal impact that they have, which drives them to improve their security posture. But a big challenge with getting any utility to improve their resilience to a particular cyber attack is the fact that it already has designed in resilience. The typical N-2 approach to electrical design has been transferred across into a majority of the engineering services that support power systems. Protection systems are at least duplicated on most lines. You'll have a first main protection, a second main protection, a backup overcurrent protection, your bus power protection. There, and then if those fail to operate, there are circuit breaker fail, systems which will then consequently trip and have an effect on the wider system. But there are huge levels of redundancy built into everything we do. In some states, there are regulations which enforce the diversity of those systems from things that are manufactured by different companies to ensure that type faults don't occur. We think about control centers and we split our functions between different sites. We think about the telecoms links that are there for intertripping and for control, and they're diversified. So we're always considering that something, one item or two items may fail. The problem is, and goes back to the point that Spencer made, is that we're talking about adversaries with intent. We're not talking about failures which are occurring in a probable way. Most utilities have got 40, 50 or more years experience of calculating how often a transformer might fail. So they know how many spares to keep. They know how long it's going to take to resolve that, and they know they've got enough redundancy built into the network. What they've not had to deal with is a transformer that wants to fail. Transformers don't choose to fail. They fail because of external factors, some of which are human driven. Sometimes they're down to age, sometimes they're down to manufacturing anomalies 40 or 50 years ago, but they're still statistically predictable. Intent is not always statistically predictable in the same way. And when you've got resilience, which is built on the idea of a thing failing, whether it's a control center completely burning to the ground, most utilities have got a plan that can handle the loss of an entire control center. Whether it's a whole protection system going, a whole substation going, it's manageable if it's caused by something that hasn't been driven by a human being. But when a human being decides to attack, they can duplicate their efforts. In particular, in the cyber world, you can attack more than one thing at once. Having resilience and through having two different vendors of a protection relay isn't really going to help you if one is from Hitachi and one is from GE, because they're both running the same underlying real-time operating system. Many of them are sharing the same Ethernet stacks. Will probably have the same day zero vulnerabilities and are using the same protocols. And quite often, because of our operational needs, we are between these redundant control centers are immediately sharing information between them in real time so that they're both capable of providing resilience. But at the same time, we're making both of those redundant facilities vulnerable to the same attack vector. So I think this is the main challenge to your utilities achieving resilience, is actually unpicking some of the things that make them resilient today, and understanding that they don't make you any more resilient to this new type of threat. This one where you've got a deliberate adversary trying to get into the systems. and that actually some of the things that make it faster and stronger in an engineering sense actually make it more exposed in the digital sense. And when utilities often have had to vehemently defend the investment that they've made in redundancy over many years, and produced a great deal of evidence to justify the right investment in the right place, they're now looking for a completely new way of describing this threat to their their boards, their own investors, and the regulators, to ensure that the right changes can be made in order to to do the right thing for society and not for their own for risks to their own balance sheet. And I think that's where it's quite different to all of those other sectors, who can can calculate the impact of something like a cyber attack, the loss of their facility, in hours, multiplying it up to dollars, and then calculating whether that's in their risk appetite. More and more other types of installation and other industries are recognizing their importance to society in the same way as utilities. We've just been through an unprecedented period over the last few years with COVID. Supply chain for food has been tested. The international dependencies of different nations on on the production of all kinds of products, from the food we eat to the every item that we consume, every piece of electronic equipment that that we use in other critical functions. All of these things have been tested. So everybody is starting to understand the importance of of their organization in those societal ways. But right now, most aren't considering themselves in terms of their impact on society, like utilities have always had to do.
So, Phil, I think that's a great point. And Christine, if you don't mind my just
please, because I was going to
jumping
ask
in
you
on
a
that.
question, but jump right in.
Well, I was going to say, Phil, I think you're spot on, and that supply chain component is so important. It's understanding where you sit in the supply chain, but then also understanding who your suppliers are, right? And the reality is, as we've seen over the course of the last few years, supply chain attacks are becoming much more frequent. Why? Well, because quite frankly, you can hit a broader net against those suppliers. But what we've also seen is kind of an economic impact to the supply chain that is creating challenges to that resilience, to that reliability, to that redundancy. You used to be able to buy OPGW, optical ground wire, very inexpensively. You could go ahead and string that, and it was 7 cents more a mile or whatever it was, than building out the regular transmission ground wire, right? So really inexpensive. Now that OPGW has like quadrupled in cost, we're seeing availability issues in the supply chain that make it so that firewall that I was going to replace this year is not available for 15 months. Those issues are creating challenges to reliability that we never really anticipated. And so when we talk about things like transformer spares, right? Do we have that sparing capacity that we had previously? And we're seeing, EEI and others have really gone in to make sure that the STEP program and we've got cyber mutual assistance and all of these things can really help us to build out a more reliable future by sharing and by mutually assisting one another. But one of the key challenges is mutual assistance is not going to be sufficient. We need to be mutually defending one another. And that means that we have to build partnerships beyond just our industry. We have to build partnerships with our suppliers. We have to build partnerships with our consumers. And we have to build partnerships with our governments in order to ensure that the regulatory pressures that may be making it difficult for us to build reliable and resilient systems are alleviated for times of emergency. And that said, Phil, I think you're spot on. The point that you made about the societal impact is critical. And I'm from New Mexico. I live in New Mexico, right? So we talk about that in terms of green chili. Whenever the power goes out, the number of claims against us because of the loss of somebody's freezer and their green chili spoiling is a quick way to assess the societal impact, right? New Mexico is famous for green chili, for those of you who don't know. So how do we get to a point where we're also ceasing to see this, regulatory pressures on our utilities for those supply chain attacks, us being responsible somehow for policing our suppliers, and have that flipped, from by the government, so that, frankly, and I know you're in the software industry, so this is a loaded question, but how do we get that to be redirected to the software suppliers who are manufacturing the systems that we do rely upon? Because that's where the vulnerabilities are from a cybersecurity perspective.
Yeah, I think it's, yeah, sorry, go on, Christine.
No, you go ahead, Phil. Go right on.
I would say, just strongly agree there. I think there are some big challenges in getting regulators to recognize that in order to move forward to a position where we are able to be as resilient around capabilities like firewalls, as we are for things like transformers, we need to be thinking about replacing them a lot more frequently and planning that in advance. We're all very, very reactive right now when it comes to dealing with, with in particular, IT, but also in the OT space, replacing those technologies in a timely way. There are still a lot of utilities that are depreciating those assets over exactly the same amount of time as they would depreciate their switchgear. It's never going to last for 80 years, and they're not replacing it every 80 years. They are still replacing it more frequently than that. But how long do we really think that these things are going to last? And right now, there's an appetite to do more in the cybersecurity space. So the funding appears, but we can't just catch up immediately. It's decades of work. So it is about thinking about how do we, rather than just replacing everything or renewing it, it's how do we make it last longer? How can we be more robust in designing our systems? Some things absolutely need to be kept up to date all of the time. We're a threat detection company. We're out there making sure that we're dealing with the latest threats all of the time. We're constantly looking at new threat intelligence, and we need to build that into our product. We can't build a box that would just be installed and left for 20 years. It needs to be constantly managed and maintained to make sure that the right level of visibility is there. But do we really need to be building in all of the security capabilities we have on a Windows box into a protection reader? Can it be simplified? And are we better placed trying to monitor things than try and build in some of the more sophisticated security capabilities into OT assets? I worry about trying to encrypt the communications within a substation. I worry about trying to make it work with two-form authentication systems that potentially increase the level of supply chain attack by diversifying the things it needs to communicate with. But at the same time, I want to see those things modernized so that we can better monitor them and ensure that they are only doing what they're supposed to be doing and only the right people are interacting with them. And that's that's a major technical challenge for us. I think there's definitely a requirement for the validation of the supply of all the suppliers in the chain, the ability to understand what's in the products. It's another challenging area, but how are you going to work with vendors in the future to ensure that they can demonstrate that they understand what's in their products? Have they got a software bill of materials? Do they understand the vulnerabilities that they're exposed to? Do they understand the potential manipulation of some of the components that they may have used from open source libraries or even other bought-in components that could, in theory, be used against them? I think it's an obvious area to look at right now is how can we encourage OEMs as customers to make sure that all of these elements are at least being discussed. Are all software companies going to let you see every component that's inside of their system? Probably not. There's still a lot of challenge around intellectual property in this space, and how things are built. Even if it's built from an amalgamation of other people's components, is still someone's intellectual property. But having a mechanism by which it can be validated so that you can quickly and clearly see which vulnerabilities you're exposed to and so that those things can be mitigated as necessary, should they be found, is important. And not establishing complete trust in any one thing, I think, is absolutely vital as well. It's for many organizations, things like the SolarWinds attacks didn't have an impact, even if they had the exploited and vulnerable versions. If they had well configured firewalls on the outside, there was no ability for that system to communicate with its, with its C2 servers and its command servers. So not every organization is exposed if it doesn't automatically trust every component within its system. And I think that's trust is an important thing. It needs to be, we need to have a lot of mutual, distrust in the most respectful way possible. We don't expect to be entirely trusted as a vendor in any, at any time. We should be only given what is absolutely necessary, and that keeps the attack surface down.
Oh, well, thanks for that thought there, Phil. And totally, we've touched on so many different interesting threads, to go in different directions. I was hearing about, we've talked in the past about how we used to think of data as, the availability and integrity. Now it's solutions, systems have to be available and have integrity in order to have that resiliency. So we're kind of expanding out that idea. And at Portland General Electric, you just put in a whole new control center. How did cyber resiliency play into the plans that you put together for that center? And have you seen a ripple effect in procurement decisions and plans in the rest of the organization?
Yeah, that's a great question, Christine. So I will say the cyber resilience and resilience in general was a huge primary driver for the development of that new control center. As a basic operational component, our existing control center was in downtown Portland area, which for those that know, we're in the kind of Cascadia subduction zone. The potential of a very large earthquake someday does exist, and that area would be prone to liquefaction. And so, the idea being that may not be inhabitable for weeks or months or years after that event to operate as a control center. So just at a very basic level, we need to be geographically somewhere else. But then thinking through that whole process of what are the groups that need to work together? We get to design this from scratch, something I feel like in the utility industry, not something we often get to do, since you're working with assets that have been in service potentially for many, many years. So getting all of those groups together and saying, well, we have our power operations folks, we have our transmission folks, we have our grid operators, we have a new automated distribution management system. How do we get all these people in a physically kind of the right contextual relation to each other, and then build on that with the systems, thinking, well, we're going to have this location here. We have our integrated security operations center and our integrated network operations center also physically within that environment. So we've built that environment to be sustainable for several weeks, independent of any kind of outside influences. So, obviously power, food, wastewater, all of that kind of stuff. But then also, can we operate within that with the technology? Have we built that around having that accessible and functional if we don't have access to outside public internet, or we don't have access to some of our microwave facilities that are transmitting data? So that was a huge part in kind of designing the functional space of that control center, and then being able to drive that down into the processes. Simply putting people next to each other is not going to solve the challenge of how do you interface with each other. And I know Spencer talked about that as well in the people processes component. So how do you then take advantage of the geographical changes or the space changes that you've created, and then the technology changes that go with it? It takes a whole thought process behind it, kind of looking at your processes, trying to figure out what your outcomes are. How have those changed based on all of those components that you've now added or changed in it? And then try and do that looking ahead, 20 or 30 or 40, 50 years, which is no easy feat given the rate of change within the utility industry. But trying to kind of see around the corner and say, how would we operate if this were to change? What systems should we have in place today? How should we diversify those? How should we build those? How can we build the resilience into it today as best as possible, knowing they may be in service for a very long time?
And just to continue on that point then, for, we talked a little bit already about, getting boards and regulators and everyone involved here. And I'd just like to, explore that a little bit more in terms of that whole concept of cyber resiliency. How does that play in utility boards at this point in time? You're both investor-owned utilities, so the answer, of course, would be different if you were, a muni or a co-op. But how does that play? What was the process of getting your boards to understand the concept and the importance of cyber resiliency? And totally, I don't know if you want to start, and then I'll go to Spencer, because I can see he's ready to burst at the seams there with an answer too.
Yeah, so I'll say I feel very fortunate to work for a company where I don't feel like we have to educate the board on that. I feel like our board is very conscious of the effects and dependencies from a cyber perspective. They are, and our officer group, same. They are driving us to do more. And I'll say, like, after the Colonial Pipeline incident, our CEO was very, very clear with us. There is no appetite to shut off any of our services in an adverse event. It is just not a thing that we are going to support. You must figure out how to continue to serve our customers through that type of event, or similar adversarial impact. And so that is, from my perspective, it makes it very easy, right? You now have the support of the board and the officer group to go and do some of those things that you might otherwise have a challenge. Our CEO has been very clear that she will tolerate some business disruption in order to move cybersecurity further, because that seems to be one of the greatest impacts that we have, right? We're going to make a change. There are groups that are trying to, keep things reliable from their perspective. It's going to have impacts on their systems. How do we manage moving the needle on the security side without being overly impactful, and doing it in that planful fashion is very, very helpful from the perspective of doing it in advance. Don't wait until it's an emergency and something happens and then try and understand how those systems work. And then I'll say lastly, like, our board is interested in getting that educational piece. And so we, had a tabletop last year with our executives where we actually sat down and went through a ransomware event. Found that very, very helpful on the decision-making process. This was just all of our officers, a number of managers throughout the company, and we learned a lot from that. The idea that you're trying to decide, would I pay a $10 million ransom during this event? And then the power ops individual pipes in and says, we could be losing $10 million an hour due to loss of economic dispatch. So while you guys squabble over that, we may have already lost that much money or had that financial impact. And so just getting those people together and having that discussion early on is very, very helpful in knowing what that would look like during a real event. And then our board is constantly educating themselves. They want to go out and see what the impacts are. They want to understand the events and the thought process. They're going to go do, as they're part of their next retreat, they're going to go do a ransomware exercise. So again, very fortunate from our perspective that we don't have to push them to that side. They understand the impacts on society and how important digital assets are to our operation. But I feel like that engagement is key to any level of success.
Thanks for that, Tully. So Spencer, and then let's turn to Phil, because you can give us, kind of a broader picture of what you see across, a number of different utilities. But Spencer, what is your take on board involvement, and how do you educate them? What was that process like? And even if you want to, venture into the regulatory area too, if there's activity going on there to educate them as well.
Absolutely. So, and one of the things that I would, and the reason that I was smiling and almost started laughing when you asked the question, was because I look at my career, and I've been in the utility industry since 2004. Board education in 2004 versus board education now is a very different question, right? And I can almost like divide it up into eras. 2008 Target, right? That changed the landscape. The board suddenly became interested, right? 2010, 2011, you started to see, additional cyber events happening. Ukraine comes along, and boy, is the board of the utility engaged, right? Colonial Pipeline happens, and suddenly anyone who's got a dependency on gas is absolutely ready to jump to do whatever it's going to take, right? The reality is our boards could not be more engaged. Kind of like, when DHS asks if your shields are up, the answer is we can't make them go higher, right? Of course the shields are up. Not only are the shields up, we are engaged all the way through our entire organization. The question becomes, how do you sustain a continued increase of cybersecurity without changing the conversation to cybersecurity is a part of everything that we have to do in order to build resilient, reliable, and redundant systems, right? So from our perspective, we look at this as we have the S3R3 methodology, right? So simplify, standardize, and secure to keep it resilient, redundant, and reliable, right? And by doing it that way, what we're really talking about is the investments that we need to make as an organization are not just in cybersecurity. It's not, are you spending, $418 million in cybersecurity this year? It's, are you spending $418 million to make your systems reliable? And cybersecurity is an integral component of everything that we spend and everything that we do, right? And if we can get to that as an industry, we cease to have some of the real, I'm going to say, much like Tolly, we're going to lose $10 million a minute in this, or an hour in a cybersecurity event and a ransomware event if we're unable to distribute or transmit power, if we're unable to meet our transmission commitments, right? The reality is we're going to lose money. We're going to lose our customers. We're going to lose critical infrastructure that's dependent upon the electric utility infrastructure. We're going to lose the ability of the United States to project power, or of your country, right, to project power if we're not providing power. So what is the societal impact of this? The board understands it. Now what we've got to do is to turn this into a business proposition that is not about, let's add one more cyber thing. I don't need yet another tool. Okay, what I need is a resilient design. I need architectures that are antiquated to be upgraded and modernized. I need systems to be made redundant. I need to be investing in fire breaks around my transmission lines, right? Live in New Mexico again, wildfires, right? And tis the season. We need to do those things that make us reliable. And we need to be investing in those things that make sure that resilience is a component of everything that we do. But most importantly, cybersecurity is an integral component of resilience. And that's the messaging that we need to be advancing to our boards now. It's, you know what, I love the fact that I've got budget. I do. It's a good thing, right? But I really want my transmission engineering group to have budget, and I need them to be engaged with me, right? As we advance the technology of the future. I need my power operations team to know that they have the budgets necessary to make the changes that they need in their SCADA and control systems, with the cybersecurity team engaged, and with suppliers who are understanding of their role in securing this critical infrastructure. And that requires spend in areas that are not, quite frankly, under the CISO.
Mm-hmm. Mm-hmm. That's a very good point. And there's this common theme again about what we at EPRI would call intrinsic cybersecurity, that it's built in instead of bolted on. We even, for both Tolly and Spencer being EPRI members, that we've developed that whole roadmap, which kind of lays it out for the whole industry here.
Right.
So it's good to hear, and that there's a linkage between intrinsic cybersecurity and cyber resiliency. So Phil, from your perspective, when you're talking to and all the different utilities that you deal with and such, are you hearing the same thing that we've heard from Tolly and Spencer, that boards get it, or are there some outliers there, or are there any stakeholders that need to have a better education in order to understand what the importance is of cybersecurity or cyber resiliency?
Yeah, the good news is it's like living in an echo chamber. Every utility is saying the same thing, and the great news is everybody's saying the same thing from a similar level of maturity. These are very, very mature conversations that people are having now around cybersecurity. I've been dealing with cybersecurity in this industry now for long enough that the typical topic of conversation at every conference was, how do we get board engagement? How do we get more budget? Be careful what you wish for.
That's right.
Board engagement is great because the language of cybersecurity has become normal it's in the normal executive dictionary now. It is, people understand the terminology, they understand the language, and they can ask very, very intelligent questions. It's also through there's a great deal of proliferation of information around cybersecurity events. No longer is it in the back channels of those of us who work in infosec. Now it's this is in the normal typical executive press. So once you've managed to shoehorn your way into the boardroom, and then it becomes a normal reporting cycle, the next thing is dealing with the spin down from every single piece of information that is heard by the board. That sort of that new day zero that somebody has decided to try and capitalize on. I know many security vendors love to push out the latest new branded vulnerability that they've discovered, not really thinking about the consequence to the potential customer they're desperately trying to sell to. And those things hit boards now, and they generate questions for those people. And the obvious answer is, yeah, of course we know about this. Yes, we're already dealing with it. You don't need to know the details of how well we're patching that particular vulnerability on that switch. You need to know how is that affecting our overall risk posture. We want you to, as boards, to have confidence in what we're doing. And we actually probably want to get to a position where it's become so normalized that it isn't a topic on its own. Exactly as Spencer was saying, that it is just embedded in operations. That cybersecurity isn't an additional and extraordinary cost, but it is built into the rate cases that we have on a repetitive basis. I think right now, globally, seeing regulators responding to the new emerging need to do cybersecurity as a separate thing, and in a very positive way, and providing recoverable funds for utilities to do cybersecurity work, which is excellent, even beyond the typical regulatory compliance requirements, but dealing with things that are necessary to manage overall risk. So we're seeing that happen, but I think we're probably a long way off the regulators just expecting that to happen and be embedded within the replacement of these systems. Right now, if you're doing something like an ADMS system, and modernizing your distribution networks, trying to get further connectivity, cybersecurity will be a separate line, on that justified investment. I can't wait for a time when utilities just get enough money to build it in a cyber secure fashion and don't have to continue to justify it as an additional expense. It's absolutely fundamental. We don't talk about whether we need to build a bund around a transformer to catch oil. It's full of oil, and therefore it needs to be done. We don't talk about the need to build a fence around a substation. It just has to be done. So why do we need to justify the require a demilitarized zone around a SCADA system? It's there's definitely still a way to go in getting everybody talking the right language, but but in the utility space, boards are engaged. The frustrating thing, I suppose, is the fact that we're in a world where the resources to resolve these things are very constrained. We don't have enough people with the right skills we think, think cybersecurity is a shortage, a shortage subject area. Try finding protection engineers, and then try finding protection engineers that understand networks and cybersecurity. That is, that's a really, really rare breed. And so we've got a particularly unique challenge in that I believe there are 10 times as many researchers who could find the vulnerabilities in these boxes than the number of people who know actually what that box does and how to configure it and how to put settings in it. So there are there's even less opportunity to find somebody who can truly understand the potential impact of some of those vulnerabilities on the power system. And that we do need to find a way of ensuring that we are, although we're engaged and we have budget, we are building skills for the future to try and to maintain these systems in a cyber secure fashion. We recognize that it will take more people in the future than we currently need to do, because not all threats come from outside. Some threats come from inside. That means more internal checks, more process to follow, more governance. There's a lot of good stuff that can be learned from the IT world that can be taken over into the OT world to ensure, good governance. There's an amazing amount of rigor in the commissioning processes for OT systems, but the change management still is not as good as it is in the IT space. The people with the right technical skill are definitely doing the work, but are they doing it in a way which is audited and checked in the same way as in the IT world? I don't believe that that's the case anywhere. So I think there's overall, we have that engagement at a very high level as an individual topic. We just need to find a way of embedding it into the businesses so that it, the way in which the threat manifests is understood, and those people who absolutely understand how the system is engineered can see how the problems might manifest, and they can engineer the new types of resilience in the future.
That's right.
So it sounds like there's a lot of
from the audience.
Oh yes, Matt, I was going to get to that because we've been talking for almost an hour, and I'm sure there are some questions out there from the audience. But what I just want to summarize here is that so top level they get it, and we got to still make sure it diffuses down to the rest of the organization, as we're also building up new resources in terms of more people coming in from more diverse backgrounds, to get back to a point you made there earlier, Spencer. Okay, yeah, Matt, let's hear what the audience is wanting to ask. Give us a couple of questions.
Absolutely. So one that recently came in on the last question you asked was, do any of you have any hard statistics on cyber events that directly resulted in loss of power to customers? How prevalent and common is this?
So if you don't mind, I'm going to take a crack at this. No, but what I will go ahead and say is that I know there are several researchers out there who are doing exactly that. They're starting to pull together events. Bob Radmanovsky over at Infracritical, to give a shout out to my friend and former colleague, is trying to build a product called Skidmark, which does exactly that. It's, I'm sorry, weird name, but it's taking together those pieces of information that are indicative that there was an ICS attack, and then putting it together to say, yes, this event was related to cybersecurity. But, most of us, this is still rare enough to make the news, and that's one of the things that I think is important to recognize here. What we're recognizing is the possibility that it can occur, and recognizing that we don't want unintended consequences. This is why we're paying so much attention to it as an industry, and why the government our governments, right, are so engaged in this particular discussion. We know the art of the possible. The question is it the art of the probable? And that's one of the key issues that I think all of us are experiencing right now, is trying to, tamp down the fear so that we can deal with the reality and the operational realities necessary to keep the lights on and the beer cold.
I really just resonate that, there is no place for FUD in our industry. We do not need to create fear that, the likelihood that the lights are going to be switched off is imminent. It's an incredibly complicated task to do it. It absolutely is possible for somebody to take control of a utility, and we've seen it in Ukraine. Ukraine, for me, when I was in the power industry, was the smoking gun that really galvanized everybody to understand the threat was there and real. But adversaries need to have both the capability and the intent. And we are so important as utilities, to society, that it would be considered very differently by every government. That that if there was an attack, it's beyond criminal. For somebody to try and extort an electricity network or a gas utility from providing their services for fiscal reward. It would be, I think, immediately construed as being a threat, to society. So I think there's a reluctance, from the capable attackers in the criminal sense, from stepping over that line. There's also this, there's a lot more defense in place, and there are much lower hanging targets. We've seen, in particular over the last year, a significant rise in the number of attacks affecting ICS using commodity IT ransomware. There was a vast number of real life incidents which prevented manufacturing plants from operating, which have impacted the supply of of commodity goods. And and like in the the colonial incident, it isn't always the OT that's impacted. It's the IT systems that allow you to have visibility of of what your commodity is flowing through that asset, and how you generate your revenues from it. And it was great to hear Tony say earlier, the perspective on it's coming from from their exec there, that you'll keep the energy flowing. I think there are most electricity utilities would take that sort of that sort of supply first, bill later approach. If the equivalency would be probably losing the revenue systems from an AMI, automatic meter reading, or so not being able to generate billing isn't going to make any of the the power utilities in the US switch the electricity off. It's quite a different approach that will be taken there. But yeah, right now there the examples of electricity power grids that people are clearly aware of are limited to those that have been published. In particular, those the 3 attacks that have taken place in Ukraine. On the electricity networks, both the Obelenkos, the distribution companies, which 2015 and this year, and and the attack on the transmission network in December 2016. They are the attacks that have taken place and had some operational impact. The reporting of the one this year has been that there wasn't a specific supply issue created. I think though that latter example just goes to show that opening a few circuit breakers doesn't necessarily mean a loss of supply. The electricity network is a complex thing in itself. We have probably though seen hundreds, if not thousands, of examples of people misconfiguring systems. We've seen maloperation of protection systems. We've seen misconfiguration of SCADA systems. We've seen erroneous information sent through through telemetry. Those things aren't necessarily classified as cyber because they're not done with intent. But they could just as easily have been done through intent, if not, if in some cases they're negligence, in some cases they are complete accidents. But we can still understand the potential impact of things by looking at at what has occurred out there in the real world, and understanding that an adversary with the right intent could do the same thing. I've seen multiple HV transmission circuits simultaneously trip because of erroneous signals from GPS satellites. I've seen, I've seen, circuit breakers spontaneously open, based on transients that they should have just ignored. These things occur because of glitches in software or the configurations of systems, and are great examples that we can look to prove that these things are real. What they don't demonstrate, that actors have a greater amount of intent, than to make those things occur, because right now it isn't happening a lot, and but it's absolutely possible, and something we all need to watch and defend against. We're defended because of our historic good practice, our historic defense in depth in the electricity industry. We have convergence between IT and OT, but they are at least separate. Other industries, there is no separation like we have, and I think that's in electricity and gas utilities. So I think it's quite important that we recognise that people have been doing things pretty well for the last 20 years, and just need to continue on that journey and keep improving them.
Well, thanks, Phil. I don't know, Toli, if you have anything you wanted to add there.
Well, I was just going to take both what Phil and Spencer said and read into the question a little bit and say, in the absence of having those stats, I think that's one of the challenges in presenting to executives of why should we do this? How do we measure success? And from our perspective, or my perspective, it's about having a framework for how you measure your risk. And Spencer talked a little bit about the failure modes and effect analysis. Can I detect this event happening in advance? Can I detect the fact that this device is being misconfigured, whether it's intentional or mistaken, and then take action on that? So I think being able to put together some metrics, understand your posture, understand where those events can happen, and then put together the processes to respond to is one way, in the absence of being able to measure how likely is an event, because we just don't have the statistics to be able to do that.
So are you thinking, Toli, in terms of like, the NIST cybersecurity framework of, protect, detect, respond type of, metrics?
I think that's absolutely one that you could use. We actually are using more of the failure mode and effects analysis to rank our risks, whether it's the NIST CSF or their risk management framework. Just having a means to look at it structurally and say, this is more important than that. We're making progress in this one, we're not. This is how bad things happen. Here's what we do to mitigate against that. To Phil's point, the intent may or may not be there, but the bad thing can happen either way. You don't want it to happen in any event. So being able to just measure and take action on that in advance, I think, is one way to do it, in the absence of hard stats on this happens, daily, weekly, hourly.
Okay.
Yeah.
Okay. Well, thank you.
If you don't mind, I just
sure.
I'll just jump in on that real quick, because failure modes and effects analysis, I want to call this out as a concept and make sure that everybody understands it's an engineering discipline, which means you can capitalize a failure modes and effects analysis. But for whatever it's worth, that means, for those of you who are utilities, you can do this as part of your engineering discipline, right? It's just make sure there's a cyber engineer in that room, right, to have that conversation, and be sure that you're doing that as part of your design basis. The nuclear industry does a really good job with the design basis threat concept and their failure modes and effects analysis work, right? But we don't do that everywhere. Why? Because it's hard, it's expensive, it's difficult, it's challenging. It requires that we think outside of the box. Well, start borrowing that discipline. It's a really easy concept to get engineers to understand, and it's one that cyber people do. They may not call it the same thing, right? They're calling it threat analysis or whatever. It's the same thing, right? Let's do this work together and really build out a design basis threat for our organizations, our entities, and then work those down. And that's all I'm going to say. I'm sorry, Christine, I didn't mean to jump in.
Oh, no, that's fine. I was just going to turn back to Matt, because I think there might be some more questions out there, because we had a great question there. So let's see if we got maybe a couple more, because we have a little more time here, about 20 more minutes to go. So let's see how many questions we can answer.
Absolutely. We have a couple more good ones. You're right. How about this one? What role would you like to see regulators take in addition to approving capital investment?
Which regulators? Sorry, so recently, and to get on the policy side for a minute, what we've seen, we saw the White House, for instance, send a letter to the governors of each of the states to tell them that they should encourage their utility commissions or their resources commissions to regulate independently. And my challenge with that is if we have 50 here in the US, right, 54 different regulatory commissions, 54 different opinions and different regulations and regulatory structures, then what we're going to end up with is 54 different ways that we have to do business here in the United States, which is impossible. Okay, we need one way, and and it's not another framework. We have 1,000 frameworks already in existence. Let's pick one and say that's the one, right? Um, what way would I suggest that regulators get involved? Ask questions. Ask questions of us. Invite us to come and speak, right? Whether we can't share everything because, quite frankly, we're not going to provide a pathway to attack in a public setting. But what we do want to share is how we go about securing our enterprises, because it's very important to us. It's something that we all engage in on a daily basis, and we're ready to answer your questions. And I can't speak for every utility, but I can tell you every utility that I've spoken with has said the exact same thing. So let's not over-regulate this space, because there are lots of good, solid practices that already exist that are effectively regulated. Let's make sure that we're adopting those practices and adapting to a world where we're making sure that our regulatory commissions are acting like our boards of directors and asking those solid questions.
Any thoughts of echoing or contradicting what Spencer just said?
I think that pretty much nails it. We've got utilities of massively different scales in the US, from co-ops through to to multinational investor-owned utilities, and they don't operate entirely within the boundaries of a particular state. The utility I work for operated in 2 different states, but was an amalgam, 3 different states, but it was an amalgamation of 6 different companies, each with slightly different approaches and policies. And it's incredibly difficult to come up with a global approach to managing your corporate risk when there are so many different implementations of something which has the same sentiment. And what is accepted as compliant in one area may not even hit the mark in another state. Some of the the concepts outside of the cybersecurity regulations are also sometimes contradictory to the need to to secure systems. It is not a US specific challenge. It absolutely has manifested in Europe as well with the the NIST directive, which was a fantastic concept coming out of the European Union. Once that was turned into national legislation within each of the member states, it had changed, and then it gets pushed down into different countries. And there are examples where you've got an HVDC link, which is effectively completely self-contained piece of technology. You have a converter station at each end and a cable that runs between it, and a single control system joining both ends together, where they've got different sets of standards at one end to the other because they're cross boundaries. That example exists in the US. There's HVDC links in like from Canada into the US, where the only the final terminal on the line is governed by NERC CIP. It's very, very difficult to ensure that each party and each owner of those assets is going to to try their best to maintain an equal level of risk mitigation if they're driven by slightly different standards. I suppose my one ask, if I was to ask regulators to act and think differently, would be to forget capital spend. You know, it's stop thinking about everything being capex. You know, it's a trap. You know that we're all stuck in when you're in the energy sector. It makes it a lot easier, you know, to get things done if you can capitalize. But unfortunately, you know, a lot of the ways of modernizing, in particular enterprise IT, are going to be OpEx solutions. You know, it is going to be an adoption of the cloud. It's an adoption of somebody else's stuff that you're using in the most cost-effective way possible. It should be about total expenditure and, you know, and delivering value to the ratepayers in, you know, and whilst delivering secure systems. And you know, the push towards capex often, I think, is holding back technology and holding back security at the same time.
Totally. Any last words?
I would summarize it from my perspective, like incentivize improvement. So, you know, not punitive. I think focus on the what and the outcomes, not on how you accomplish that. And then just giving clarity, right? Clarity, and whether it's in rate recovery or in the direction that you're going, so that you're not kind of chasing the regulatory whim of the month, year, decade, and instead really trying to achieve those outcomes. You're making secure systems that are resilient.
Okay. Matt, that was another great question. Do you have another one lined up for us?
I sure do. So this one came a little bit early on, and I think Toli, at one point you were talking about the training and retreats that some people on your team had done. So the question was, what are, you know, a little bit more about your backgrounds and how each of you, you know, got trained up and prepared for your current roles?
I guess for me it was accidentally. Like I got an engineering degree. I did not like the power system stuff at all, and then I found myself working for a utility. So already right off the bat, unintentional, did telecom stuff. So I just happened to kind of wander my way through a utility background. Got started in NERC-CIP compliance stuff very early on. You know, right after the kind of urgent action 1200 in the 2003 timeframe, and then followed that through understanding the systems. I feel like I've moved around in different places within the organization, so that just has been very beneficial to me. I've gotten to see how a utility works, so that security is not an add-on for me or an afterthought. It's like, how does the system function? Then how do we implement, you know, resilient systems as part of that? Obviously, there's a lot of training and various aspects that you can take, whether it's getting certificates or you know, taking advantage of some of the fantastic things offered by SANS or other utilities. EPRI is another place. You know, we take advantage of the trade groups. EPRI and EEI are places that we've really used to go in and learn and understand and compare with peer utilities. I think that's a lot of what I really take advantage of. Is there's so many resources out here, and I love the utility space because we are not competitors in many respects. We're all working towards the same goal, and so you just find this level of willingness to share and teach and learn that you don't see maybe in some other respects. So I don't know if that's particularly helpful, but I kind of wandered through and kind of just ended up where I am.
Bill, how about you?
Go next.
So I'm a product of my experiences, and I think that's a problem for us in the industry. I hear so many people, you know, that you know, use the, you know, the same story as myself and Toli. You know, we've become experts in what we do in this, you know, quite unique niche, which is great as a, you know, as an individual. You know, I love the job security that, you know, being an expert in cybersecurity in this industry gives me. But I'll have completely failed if when I leave this industry, it's just not a normalized skill. You know, I think it's so important that we find ways of giving people those skills proactively, rather than hoping that they get them through, you know, a collection of experiences that just happen to have occurred to them along their way. You know, I started off in, you know, working in substations, maintaining equipment. You know, I often describe working in substations as mechanical engineering. You know, I was stripping down circuit breakers and maintaining them. I was climbing inside of online tap changers, and I had this curiosity about how the the other equipment that controlled them, a majority of which at the time was still electromechanical relays, and it was understanding the mag curves of a coil, not and understanding how timers worked, and that logic was was like analog computing, and it made sense to me because I had an engineering background in electronics, and I could I could see where the future was going. I pivoted around. I moved in, in and out of engineering, and into the IT side of things, and I came back into the operational side of things when we were implementing Ethernet networks in order to do modern condition monitoring systems. And it was that combination of being a technologist and an engineer and being passionate about the energy industry that that meant that I was always in the right place to to gain these new experiences and to think about these new cyber threats. And when I was ultimately responsible for the integrity of all of the protection and control assets in the UK electricity transmission network, I had a team of engineers who were great at understanding how to fix things when they went wrong in a normal way. It wasn't a challenge. We were excellent at dealing with with maloperations and ensuring the operation of the protection systems. It was very repetitive. The challenge was the new thing. It was cybersecurity, and so I went out there and I explored it. And being the first people to get involved in these things and to to get involved in the programs, was the thing that has led from one experience to the next. Early on I got I got visibility of what was happening in the the EPRI P183 program, and seeing the work that was happening across the Atlantic, that it brought me over to the to the other side of the Atlantic. I got to speak to my peers in the US side of the transmission business, and that led me to the distribution side. Each of those things has contributed to my experiences. Not everybody is going to be that lucky, and we're never going to generate the volume of people we need by relying on those things. We need to be introducing everything right from apprentices. I want to see people coming from school straight into programs where their job is to be a cybersecurity engineer. And by security engineer, I don't mean the new term engineer. I mean people who understand the physical world in which this equipment needs to operate and can put the right controls in place.
So I'm going to be the odd duck. I was in high school. I became a Tandy certified computer repair technician working at a Radio Shack. I left. I went to college where I majored in philosophy because I didn't have the math to do this job, right? Or any job really. I went into the Army. I went into law enforcement. I became a crime prevention specialist. And my chief of police walked up to me one day and said, "Hey, you know those computer things, right?" I said, "Well, I guess." He said, "I want to send you to an FBI school." So I went to the FBI, where I went through the National Infrastructure Protection Center. I was also the webmaster for the police department, amongst other things, right? I got a phone call one day. I had gone to Baltimore for the very first time. And on my way home from Baltimore, I got a phone call asking if I would be interested in applying for a job with a utility company in Baltimore, Maryland. And I was like, yeah, right. Who is this? Because I was literally coming home from Baltimore on my first trip. It was weird. And from there, I kind of worked my way through every job in cybersecurity, every job in physical security. And I did this for my entire career. And what I've learned is to stop thinking about cybersecurity as an engineer, as a technologist, as a police officer, as an incident responder, and to start thinking about cybersecurity in terms of your business, right? And what is our business? Our business is to deliver electrons to people. How do we ensure that we do that? Okay. It's led me through crisis management. It's led me through policy discussions. I'm not a lawyer, but I do occasionally play one on TV and argue with our own attorneys, right? And that's the thing. It's a very multidisciplinary approach, but it's also a multidisciplinary problem. And everybody thinks about cyber as, oh, they all go to an NSA Center of Excellence school and they learn about cybersecurity when they're new in this field, right? And what did they learn? They learned to pen test. What we're doing is we're training a nation of attackers. We need to be training a nation of defenders. So to that end, I actually am part of a cybersecurity program here in New Mexico at New Mexico Tech. Not to do an ad, but I will real quickly. And we've got a PhD program in transdisciplinary cybersecurity. And what it's about is engineering and ethics and legal and policy and regulation and all of the components that we've just discussed. There's a great deal of technology that goes into this, but there's also a great deal of every other discipline in the world. Because quite frankly, security is about preventing a crime from occurring. And that, back to my very foundational role in law enforcement as a crime prevention specialist, is still the most important thing. It was my very first lesson learned, which was I didn't have to go and talk to a victim if I talked to them up front and helped them to prevent it. And that is the mission here. And the mission in law enforcement was, you're helping society, right? And not everybody looked at it that way. And in this day and age, nobody looks at it that way, except maybe still me. But the reality is, law enforcement and crime prevention gave me the foundation that was necessary to think about this problem in terms of helping society. And that's what the utilities do. We provide power, and we provide life-sustaining power for every one of our customers. Without what we do, people die. Without what we do, there's no water pumping in the desert. Without what we do, there's no clean water, right? What we have to do is to keep that on for civilization to exist. And I think it's critically important. And I mean, Dragos, stole the motto. I mean, no, I'm just kidding. So, but they are protecting civilization, and that's what we do every day. So that said, I think it's an important mission, and it's one that's forced me to understand not just my utility space, but to understand how everything works so that I can focus on how to make sure that it's done in a secure and safe fashion.
Matt, I think we would have time for one more question if it were one that was like a yes, no, or framed into like you have 10 words to answer this or something like that. Is there a question that could fit in that category?
Oh, putting me in a box there. Let's see. Well, I'll go for the first half of this question then. On the topic of supply chain and misconfigurations, are third-party vendor services increasing cyber risk to your environments unintentionally?
I would say not unintentionally. It's absolutely necessary to have methods of connectivity into site. We can't air gap OT forever. So many systems, they're complex. The expertise and knowledge to support them sits with the vendor. I think the real solution to the problem is to have good, secure, asset owner provisioned remote access. No proprietary remote access systems for each different vendor the way that they want to do it. Do it the way you want to do it as an asset owner and operator, and monitor what they do and monitor the networks that they're connecting to. You can't stop businesses from progressing.
I agree. I would go so far as to say there's no such thing as an air gap, but more importantly, there's no such thing as a utility without a supplier. We don't build our own industrial control systems. We don't code things on our own anymore. I mean, there are the occasional kludge that's out there, but the reality is we are fully dependent upon our supply chains, which means that stop regulating the utilities for code, right? The reality is we need those suppliers, those vendors, those purveyors of industrial control systems to be regulated as the critical components of our systems that they are.
Foley, you get the final word here.
Nothing more to add. I think the answer is yes. Yes, they do add risk to it, and you're going to manage that the best you can. It needs to be a well thought through plan. So,
hey, we have hit the end of our session here. So thank you, all three of you, Tolly, Spencer, Phil, for a wonderful conversation, and I think it was quite informative for everyone. And I'm going to turn it now back to PJ to wrap this up.
Thank you, Christine. Thank you, panel. Fantastic conversation. For our audience, look for an email from us to contain the link to the replay in case you missed anything. And please take a moment to fill out our survey that will be popping up as you log off. We really appreciate your feedback. And of course, we want to especially thank Dragos for making today's event possible. From everyone here at Energy Central, we want to thank you for attending. Thank you, panel, so much for taking the time to be on. This now actually concludes today's presentation. Have a great day, everyone.
Thank you.